The very first question here comes down to talking about square roots. And I think that what you need to do in order to be able to understand the square root is to make sure you understand squaring first, because they're linked together. What one function does is it undoes the other function. And the analogy I like to think about is like you wrapping a gift. Okay, so the function is wrapping, and then how do you undo that? Well, you can unwrap it, right? And so wrapping and unwrapping, they undo each other. So squaring and square rooting, they undo each other. And what you get is the original object inside. Now, when I think about squaring, and you can square all kinds of numbers, positive and negative, but the point is that if I square, for example, the number 3, you know I'm going to get 9. If I square the number -3, what am I going to get there? And the answer is also, I'm going to get 9. So if I'm going in this direction, right, from right to left, left to right, this concept here, this squaring, has two different inputs that give you the same output. Okay? And so, and once again, that it's a positive 3 when you square it, you get 9, and also a -3 when you square it, you get 9. Now, what I want you to do is contrast that with taking the square root, and I'm just going to write the word root here. Okay, so now we're going in the other direction. So if I think about taking the square root and doing that, remember, taking the square root undoes the square, right? It's unwrapping. So I'm taking square roots of both things. It's the same number 9 in here, as you notice, okay? And so what happens when I take the square root of 9? Well, I'm going to get two answers, right? I'm going to get the things inside, and you can see the things inside are both positive 3 and -3. And so that's why, let me write this as, so I'm going to get 3 here, and then I'm going to get -3 here. So that's why when you square root 9, what you're doing is you're going to get both positive 3, and you're going to get -3, okay? And that's a legitimate way of writing it. And another way to do it in shorthand, and this is where the notation comes in, is by writing plus or minus right next to each other like that, and then 3. And that's the same thing as saying either +3 or -3. Okay, so I hope that helped with this first question. So remember, square root just undoes the square, and so when you wrap and you unwrap, you're just like isolating your x, right? And that's the whole point of square rooting the square, isolating that x. And so when you square root this other side, as you know, square rooting any number is going to give you plus or minus the root. Okay. Now in the next portion of your question, this was from the example in the book. And this function h of t equals is actually a piecewise function. You have -5t squared plus 100t if t is between 0 and 20, inclusive. It could also be 0 if your t happened to be strictly greater than 20. So that's how you define this function. And then your first question here says, so in the solution part it states that t equals 10. How do we know that? I'm going to assume that this part right here comes from answering the first question right here. And so if you look at this expression here, all right, that's h of 10, h of 10. And so if I point to the what's inside, that's h of 10, and then I go back to what h is defined as, h of t is equal to, right, either this or that. Well, how do we know that t equals 10? Well, these two arrows right here, they match up. That means your t equals 10 in this case. So in this case, t equals 10, and you go to town trying to solve trying to compute what happens at h of 10. The other thing that's happening here is that when you're looking at t equals 10, is you have to see which of these two domains would 10 fall into, right? Is the value 10 in here, or is the value 10 over here? Right? Because that's the question you have to ask. And so if you look at that case, you can tell, okay, well, 10 is a number between 0 and 20. So that means that it's going to fall into here. Like, this is the right case. So then we should be using the corresponding function. In this function here, that's where we're going to plug in 10. Versus, if I'm looking down here, I have h of 60, okay? So h of 60, and so if again, I look, is 60 going to be in here? Or is it in here? Now, as you know, 60 is a number bigger than 20, all right? And so that means you're in this domain. So what does the function equal when t is bigger than 20? Well, it equals 0. And so that's how you would interpret these piecewise functions.